Hello and welcome to this talk. I am Negar, and in the next few minutes I am going to briefly talk about our paper titled Discovering Language-Neutral Subnetworks in Multilingual Language Models. This is a collaboration with my colleagues at EPFL. Multilingual language models such as Lebret are pre-trained jointly on raw data from multiple languages. Later, they are fine-tuned for a task using a high-resource language dataset and are used in a zero-shot setting for low-resource languages. These models demonstrate promising zero-shot cross-lingual performance, generalizing to the same task in different languages, although they haven't been fine-tuned for those languages. The facilitator of this cross-lingual transferability is often hypothesized to be a learned language neutrality in these models, meaning that there is a shared representations that encode similar phenomena across languages. However, the source of this ability remains an open question, and there is no consensus on the extent of language neutrality of these models. Also, most of the prior works analyzed the language neutrality of multi-LMs by probing their output contextual representations. However, in this paper, language neutrality is conceptualized in terms of the parameters of multi-LMs. We hypothesize that a multilingual model with language-neutral representations would have learned different languages using the same subset of parameters. So here we extract and evaluate language neutrality of subnetworks in the model. To demonstrate this effect, and by using iterative magnitude pruning, we extract subnetworks from multi-LMs by pruning them for individual language and task pairs. And later, we evaluate language neutrality of these subnetworks by reinitializing them to the unpruned parameters of the original model, and then by fine-tuning them on task data for different languages and evaluate their cross-lingual transfer performance. Using Lebret, we extract subnetworks for MLM, NER, and XNLI tasks, and we do it for 11 diverse languages. We train each subnetwork on other languages for the same task and compare its performance against the original subnetwork trained on identical data. Our results show that the cross-lingual transfer performance of subnetworks between languages on the same task is high, and there is a big improvement over random subnetworks. High cross-lingual transfer performance of a subnetwork indicates that the subnetwork is more language neutral than language specific. As the entanglement of subnetwork decreases, we would have expected cross-lingual transfer performance to drop. Consequently, we increase the sparsity levels of our language-specific subnetworks, and we find that cross-lingual transfer performance drops considerably while language-specific performance remains high. As a result, we conclude that language-neutral components of the multi-LMs are pruned in favor of retaining necessarily language and task-specific components. To summarize, we conceptualize language neutrality in terms of the overlap between language-specific subnetwork of multi-LMs. We extract these subnetworks using iterative magnitude pruning. The main takeaways of our analysis are as follows. We find that language-specific subnetworks have shared multilingual components as they exhibit good cross-lingual transfer, and they shared many parameters among each other. However, as we make these subnetworks sparser, we find cross-lingual performance drops drastically while monolingual performance remains roughly the same. This was just a brief overview of the paper, so please do check out our paper for more information, and thanks for your attention.